Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 11. Tax, yuck. Commissions, fees, and other real-world problems. They're definitely problems. All right, classwork, open exercise, tax, commission, gratuity, and fees. How are each of the following percent applications different and how are they the same? Solve each problem and then compare your solution process for each problem. A. Silvio earns 10% for each car sale he makes while working at a used car dealership. If he sells a used car for $2,000, what is his commission? So commission would be the amount he sells it for. Sell the price. How about price? Commission equals price times percent. So commission is going to equal 2,000 times 0.1, which is 10%. So the commission is $200. Okay. B. Two's family stayed at a hotel for 10 nights on their vacation. The hotel charges a 10% room tax per night. How much did they pay in room tax if the room cost $200 per night? Okay, so the first thing I want to do is take that $200 per night and multiply it by the room tax, 10% room tax per night. So times 10% or 0.1 equals $20 per night. How much did they pay for the room tax? For 10 nights, and then multiply that by number of nights, and it was $200 in taxes. And $2,000 for the room. Okay, part C. Eric bought a new computer and printer online. He had to pay 10% in shipping fees. Wow, that's a lot. The items total $2,000. How much did the shipping cost? So you take the $2,000 multiplied by 10% or 0.1, and that moves the decimal over 1, and he paid $200 to have his computer shipped. Okay. D. Selena had her wedding rehearsal dinner at a restaurant. The restaurant's policy is that gratuity is included in the bill for large parties. Restaurants do this regularly. Her father said the food and service were exceptional, so he wanted to leave an extra 10%. So he didn't want to just give them what they charged automatically for a large group. He wanted to pay 10% more than that on top of the total amount of the bill. If the dinner bill totaled $2,000, how much did her father leave as the extra tip? Well, again, that's $2,000 times 10%, and that equals $200 for the extra tip. Exercises. Show all work. A calculator may be used for calculations. The school board has approved the addition of a new sports team at your school. The district ordered 30 team uniforms and received a bill for $2,992.50. The total included a 5% discount. The school needs to place another order for 2 more uniforms. The company said the discount will not apply because the discount only applies to orders of $1,000 or more. How much will the 2 uniforms cost? So this is only 95% of the original cost. So I'm going to write the equation from a couple exercises ago, or lessons. Quantity equals percent times a whole. The quantity is 2,992.50. The percent was 5%, but they paid 95% of that. The discount was 5%, so they paid 95%, which is 0.95 times W. So 95% of some number is 2,992.50. In order to solve this, I divide both sides by 0.95. Divide both sides by 0.95. And I'm going to save time here by asking my phone calculator what this is. Hey Siri, what's 2,992.5 divided by 0.95?
1,992.5 divided by 0.95 is about 2,097.3684.
Okay, so it's an approximation. So it was about 2,097.36 for that whole bill without this 5% discount. So we found the total bill, but now we need to take this 30 and divide this by 30, and that will be one uniform. Okay, so one uniform, so that's not the whole anymore. So I'll just erase that to save time. So now we have, I'll use U for uniform, and I will just do this without my calculator. 3 goes into 20 6 times. 6 times 3 is 18 with a remainder of 2. 3 goes into 29 9 times. 9 times 3 is 27 with a remainder of 2. 3 goes into 27 9 times. And 3 goes into 3 once. And 3 goes into 6 twice. And 3 goes into 8 twice with a remainder of 2. And 3 goes into 24 8 times. So I'm dividing this by 30. So I move the decimal one more place here. So I was just dividing by 3. So one uniform equals $69.91 approximately. Okay, I have a problem here. Siri did me wrong. When I said, hey Siri, what's 2,992.5 divided by 0.95?
2,992.5 divided by 0.95 is 3,150.
Okay, she didn't say that last time unless she didn't hear me properly. So let me just fix this. So it's 3,150. 3 goes into 31, 30 goes into 31 once, 30 goes into 150 5 times. And so therefore, 30 goes into 31 once. 30, there should be a 0 in between here. That should be 105. Hey Siri, what's 3,150 divided by 30?
3,150 divided by 30 is 105.
Okay, so each uniform is $105. So if I buy 2 of those uniforms, they would be $210. How much will the 2 uniforms cost? Okay, part B. The school district does not have to pay 8% sales tax on that purchase. Estimate the amount of sales tax the district saved on that purchase. Explain how you arrived at your estimate. So you take the 2,992.50 and you multiply it by, so it says estimate the amount of sales tax. 8% is 0.08. And when I do that, I get, hey Siri, what's 2,992.5 times 0.08?
2,992.5 times 0.08 is 239.4.
Okay, so if they had to pay tax, but they didn't, the tax at 8% would be $239.40. Part C. A student who loses a uniform must pay a fee equal to 75% of the school's cost of the uniform. For a uniform that costs the school $105, will the student owe more or less than $75 for the loss of the uniform? Well, 75% of 100 is $75, so 75% of more than $100 would be more than $75. Okay? Does everybody understand that? 75% of $100 times 0.75 equals $75. The uniforms are $105. So it says, will the student owe more or less than $75? Well, if the uniforms are $5 more than this, then it's going to be 75% of $5 more than $75. They didn't ask how much, so I'll move on. D, write an equation to represent the proportional relationship between the school's cost of a uniform and the amount a student must pay for a lost uniform. Use U to represent the uniform cost and S to represent the amount a student must pay for a lost uniform. So we're trying to find S, and S equals 75% of a uniform, so it would be 0.75 times U. The constant of proportionality is 75% or 0.75, and remember the equation y equals kx from years ago, last year, 2 years ago. K is your constant of proportionality or your rate of change. So in this case, y is our S and x is our independent variable u. So therefore the K is 0.75. The constant of proportionality is 0.75. Number 2. A taxpayer claims the new sports team caused his school taxes to increase 2%. Did I finish the last page? Or is there more? That's it. Write an equation to show the relationship between the school taxes before and after a 2% increase. Use B to represent the dollar amount of school taxes before the 2% increase. So B is before, T is after, to represent the amount of school tax after the 2% increase. Okay, so what are we trying to find? Write an equation to show the relationship between the school taxes T before and after a 2% increase. So T will be the dollar amount of school taxes after, and B will be before. So T will equal the 0.02 times the before price. Okay, so if I did a table as down below, B and T, they started it for us, 1,000, 2,000. If B is 1,000, then I substitute this in, so T would equal 0.02 times 1,000. So T would equal, move the decimal 2 places. So I multiply 2 times 1,000 is 2,000, but I move the decimal 2 places to here, and $1,000 would be $20 in taxes. 1,020 with the tax. So T equals, okay, we want to know the taxes, the dollar amount of the taxes after the increase T. Oh, okay. So it's a total. So I want to change my equation. In order to do this in one step, it's 102%. So the taxes before times the 2% increase plus the 2% increase. So it would be 1.02 times 1,000. And when I do that, instead of getting the $20, I will get 1,020 by moving the decimal 2 places. So if I just show all my work here, 102 times 1,000 is 102,000, but move the decimal 2 places would be right here. So 1,020. So 2,000. So what they're doing is increasing by 1,000 here, 1,000, 2,000. So if we are going to have a constant of proportionality, the amount my B's change is the same every time. So if I add 1,000, I get this one. If I add 1,000, I'll get the next. If I add 1,000, I'll get the next. And to fill in the blank above here, I would subtract 1,000 to go the other way, and that's 0. Well, 0 times 1.02 is still 0. So now we're adding 1,020 every time, so this would be 2,040, 3,060. But this can't be 4,000, we jumped. because 4,000 would be 3,060 plus 1,020, which would be 4,080. And then the next one would be 5,100, and then 6,120. So we skipped 4 and 5, so this looks like it's going to be the $6,000 one. And I'll check. So T equals 1.02 times 6,000, and I would get T equals 0, 0, 0. 6 times 2 is 12, carry the 1. 6 times 0 is 0, plus that carried 1. 6 times 1 is 6. 2 decimal place is 6,120. So it went 0, 1,000, 2,000, 3,000, 6,000. C says, on graph paper, graph the relationship modeled by the equation in part A. Be sure to label the axes and scale. All right. They didn't give me graph paper, so I'll just bring a graph in. Okay, so here's the graph. Let me move it over so you can see the words behind it. There we go. Okay, so what do we need when we graph things? We need a title, the effects of a 2% school tax increase. We need the t-axis this way and the b-axis this way. Remember, b is your independent variable, x, and your t is your dependent variable, y. So your B across the bottom, which is original tax in dollars, all labeled up nice, and then new tax in dollars after taxes, 2% increase. And then 1,000, 2,000 up to 7 both ways. And if I graph 0, 0, it's right here. 1,000, 1,020 is just a little bit above 1,000 there, you see. 2,000, 2,000 is here. We're at 2,040, which is above 2,000. 3,000, 3,060 is here. 4,000, 4,080 would have been there. 5,000, 5,100 would have been there. Is that right? Was it 5,100? This graph isn't really correct. It's off. This would be more like 5,900. So the graph is, let me fix it. I'm having a problem with that. And let's make it red. So first pick this. Let's make it red so you can tell it's mine. And make it a thinner. So 7,000. 6,000 was 6,000. 120 is only about here. Let me do that again. See if this works. Okay, 6,000. 6,000 is right here. 6,500 would be here. So we're down at 120, which is more like here. So that's where our graph should be. So these are wrong. Okay, so if I move these down here like so, and that would be more like our graph. Okay, try to be as accurate as possible. Disregard this thicker line. Okay, is the relationship proportional? Well, with looking at that graph, I would definitely say that it is proportional. Yes, because there is a constant of proportionality, and when we check 6,000, it checked 6,120. Okay, the proof's in the pudding, right? K equals y divided by x. 0 divided by 0, you don't count that one, but 120 divided by 1,000 is the same as 2,040 divided by 2,000, and so on. They're all equal. And that's how you know. Because y over x is always equal to the same k. E, what is the constant of proportionality? The constant of proportionality was, well, if I do this, then it'd be y equals k over x. And then, hey Siri, what's 102 divided by 100?
102 divided by 100 is 1.02.
Okay, so I'm just making sure. And it matches what we had up here, which is where our constant of proportionality is. So our constant of proportionality is 1.02, but I'm going back to math 8 and 7 with that y equals, or at k equals y over x. And what does that mean in the context of this situation? That means how much the tax, that dollar amount owed after taxes increases. Okay, for every dollar, it will increase 1.02%. 102%, I should say. F. If a taxpayer's school's tax rose from 4,000 to 4,020, was there a 2% increase? Justify your answer using your graph, table, or equation. Well, I've erased the table and graph, or the graph already, so I will use the equation. So our equation was t equals 1.02b. So I'll write t equals 1.02b. So our tax before is 4,000 and our tax after is 4,020. So then I solve this, and if it's equal, the answer is yes, and if it's not equal, the answer is no. So when I multiply this, I have 0, 0, 0, 4 times 2 is 8, 4 times 0 is 0, 4 times 1 is 4, 2 decimal places, and the tax increase is $4,080, not 4,020. So that was not a 2% increase. Number 3. The Sports Booster Club sold candles as a fundraiser to support their new team. The club earns a commission on its candle sales, which means it receives a certain percentage of the total dollar amount sold. If the club gets to keep 30% of the money from the candle sales, what would the club's total sales have to be in order to make at least $500? Okay, so again, we're going to use that quantity equals percent times the whole. So our part is what we're trying to find, or our part is 500. What would the club's total sales have to be in order to make $500? So they want to make 500. What sales amount percent would we have to sell to make 500? The percent is 30%, which is 0.3, and we're trying to find how much total sales they need to make that. So if I divide both sides by 0.3, I find my answer. These cancel. 3 goes into 5 once with a remainder of 2. 3 goes into 20 6 times with a remainder of 2. 3 goes into 20 6 times with a remainder of 2. There is 1 decimal place. So they would have to make $1,666.67. Approximately. I have to round that because pennies can't just go on and on and on. Okay, so they'd have to make about $1,667.67. Okay. Number 4. Christian's mom works at the concession stand during sports events. She told him they buy candy bars for 75 cents each, 75 cents each, and mark them up 40% to sell to the concession stand. What is the amount of the markup, and how much does the concession stand charge for each candy bar? Okay, I'm going to use the same variables as before. So T equals amount after markup and B equals amount before markup. And let R equal the markup rate. Okay. So we want the price after the markup T. So we're going to let T equal the percent or markup rate R times the whole. And the whole would be this before, so let's change that to W. Just so we're still using percent times whole or markup times whole. Okay, so we want to find T equals. Now, they have to buy the candy bars. So they buy the candy bars for 100%, and they add 40% markup to them. Put my decimal in the right place. They add 40%. Yeah, let me do percent first. Let me write it like this. 100% plus 40% times the whole, which is 75 cents. Okay, the whole price with the markup. She told him they buy candy bars for 75 cents and mark them up. So she's marking them up 140%. 100% of 75 cents is 75 cents. The 40% is the amount added on. So this is going to equal 140% of 75 cents, which equals 1.4 times 0.75. 5 times 4 is 20, 7 times 4 is 28, and 2 is 30. 0, 5, 7, 0, 5, 10. One decimal place. 2 decimal places. 3 decimal places. 1, 2, 3. I'll get it right in a minute. All right, so T equals $1.05. So the concession stand buys a candy bar for 75 cents, marks it up 40%, and sells the candy bar for $1.05. What is the amount of the markup? 105 minus 75, which equals 30 cents. How much does the concession stand charge? $1.05. Okay, so you'll notice in your student edition that it says, with your group brainstorm solutions to the problems below, prepare a poster that shows solutions in math work. A calculator may be used for calculations. Obviously, I'm not going to do that because I am just doing this on my own. So number 5 says, for the next school year, a new soccer team will need to come up with $600. Suppose the team earns $500 from the fundraiser at the start of the current school year, and the money is placed for 1 calendar year in a savings account earning 0.5% simple interest annually. How much money will the team still need to raise to meet next year's expenses? Remember the equation, interest equals principal times rate times time. PRT. So I want to know what I equals. I want to know what P equals. I want to know what R equals. And I want to know what T is equal to. Okay. The principal amount is right here, $500. That's principal amount. The interest rate is 0.5% or 0.005. Be careful where your decimal place goes. 5% is 0.05. 0.5% is, move the decimal 2 places to the left, 0.005. And T is 1 year. Okay, so if I use this equation, I equals PRT, move it over here. I'm trying to find interest. That's what I don't know. That's my unknown. Okay. P is 500. The rate is 0.005, and my time is 1. So I can ignore the time because it's only 1 year, and anything times 1 is itself. That's the multiplicative identity. So I'm going to get 5 times 5 is 25. and there are 3 decimal places, but if I brought the 2 zeros over, and I moved the 3 zeros over here, from here to here, the 3 decimal places, then I get $2.50. So they only made $2.50 interest for a whole year on the $500. So if you take that $500 and add the interest in, which is $2.50, then we end up at the end of the year with $502.50. We wanted $600, so we need to subtract what we have from what we need to get the balance of what we still need. And when I do that, I get $97.50. So they still need to raise $97.50. Part B. Jeff is a member of the new sports team. His dad owns a bakery. To help raise money for the team, Jeff's dad agrees to provide the team with cookies to sell at the concession stand for next year's opening game. The team must pay back the bakery 25 cents for each cookie it sells. The concession stand usually sells about 60 to 80 baked goods per game. Using your answer from Part A, determine a % markup for the cookies the team plans to sell at next year's opening game and justify your answer. Okay, so the team needs $97.50. We need to keep that in mind. It's still on the screen up here, but I'll write it over here. They need $97.50. Based on the past data for the typical number of baked goods sold, we estimate that we will sell 60 cookies. Okay, the concession stand usually sells about 60 to 80 baked goods. Let's work with the 60. We'll underestimate first. Okay, so we want to divide $97.50 by the number of cookies we're going to sell to see how much each cookie has to cost. So I divide $97.50 by 60 cookies to see how much each cookie has to be. 60 goes into 97 once. Bring down 7, 37, bring down the 5. 60 will not go into 37, so I brought the 5 down. 6 goes into 37 6 times, but 6 times 6 is 3. That's too big, so it's going to be 5. 5 times 0, 6 times 5 is 30. No, actually 6 will work. 6 will work. 6 times 6 is 36. So 6 times 60 is 360. And bring down the 1, 5, and then the 0. 6 goes into 15 2 times. 6 times 2 is 12. Subtract and get 30. And 6 goes into 35 times. Okay, just checking. So that's approximately $1.63 per cookie. After we pay back the bakery 25 cents per cookie, let's see. Okay, yeah, so $1.63 per cookie will give us $97.50. But 25 cents has to go back to the bakery. We can't keep this whole amount. So each cookie we have to add that 25 cents in that we owe right here. And so that's going to be $1.88 per cookie. Okay, so if we round that up to $2 to make sure we raise enough money, we're going to raise it up to $2. Okay. And we don't want to deal with pennies anyway when we're selling at the concession stand. And we could possibly sell less than 60 cookies. So to find the percent markup, we use the following equation with 25 cents as the original price. Okay, so we use the equation again. Let's see. So I want to stay consistent in this lesson. Earlier we used Q equals the percent times the whole, our quantity. So if we're selling the cookie for $2 and we have to give back 25 cents, so the original, if we round it and we subtract that 25 cents that we have to give the bakery, we're back down to $1.75 as our quantity. So we have $1.75. From that $2, we're going to profit $1.75 per cookie if we sell them for 2 and give the bakery 25 cents back for each cookie it sells. So the quantity here is $1.75 equals the markup rate or percent times the original price of 25 cents. So I'm going to divide both sides by 0.25. And this will cancel, and this will give us our markup percentage. So 25 goes into $1 4 times, 75 cents 3 times, so that's a total of 7. So our markup is, our percent equals 7.0, which is 700%. Wow, that's a big markup. They should go on Shark Tank. All right, part C. Suppose the team ends up selling 78 cookies at the next year's opening game. Find the percent error in the number of cookies that you estimate will be sold in your solution to part B. Percent area was from a prior lesson in this module, and percent error is, they're reminding us here, the actual amount, or I'm sorry, the estimated amount minus the actual amount, absolute value divided by the absolute value of the actual amount times 100%. So X is the exact value, A is the approximation. Okay. So our estimate A was 60. Our actual is 78, so X is 78. So we use 60 and 78 in this formula and we're done. So we write the absolute value of 60 minus 78 divided by the absolute value of 78 times 100%. 60 minus 78 is a negative 18 over the absolute value of 78 times 100%. Okay, and this is the percent error. I should be saying that coming down here. Percent error equals, percent error equals, percent error equals, and the absolute value of negative 18 is 18, and 78 is 70. Absolute value of 78 is 78. I don't want an equal sign. It's times 100% again. Okay, so the percent error is 78 divided by, or 118 divided by 78. I can reduce that, but it's just as easy to say, hey Siri, what's 18 divided by 78?
18 divided by 78 is about 0.2307.
Okay, 0.2307 times 100% equals, with the decimal 2 places, approximately 23% is the percent error. So there's about a 23% error in our estimate for the number of cookies sold. Okay, that is the end of lesson 11. Review the lesson summary and go do your problem set.